Welcome back to Zito TechVerse. In this video, we're covering 30 SQL interview questions, from fundamentals to advanced topics. For each one, I'll read the question and provide a structured answer with a query example and a real-world analogy. Let's get started. Here is our roadmap. We begin with SQL fundamentals, move to joins and aggregation, then tackle advanced queries, and finish with performance and design. That is 30 questions in total to help you prepare. Section 1 covers SQL fundamentals, the building blocks of everything we'll discuss. Question 1. What is SQL and what is it used for? SQL is the standard language for relational databases. It handles CRUD operations, creating, reading, updating, and deleting data. It is declarative, meaning you define what you need, and the engine determines the best execution path. While standardized, most engines include custom extensions. Question 2. What is the difference between where and having? Where filters rows before they are grouped, so it cannot use aggregate functions. Having filters results after the group by operation, allowing for aggregate tests. Use where to reduce your data volume first, then use having to refine your final groups. Question 3. What are the different types of SQL statements? They fall into 4 categories. DDL defines structure, DML manipulates data, DCL manages access permissions, and TCL handles transaction controls like commits and rollbacks. Question 4. What is a primary key and how does it differ from a unique key? A primary key uniquely identifies a row and cannot be null. A table can only have one. A unique key also enforces uniqueness but allows nulls, and you can define multiple unique keys per table. Question 5. What is the difference between delete, truncate, and drop? Delete removes specific rows and can be rolled back. Truncate removes all rows quickly but cannot be rolled back and resets identity counters. Drop removes the table and its structure entirely. Question 6. How does null behave in SQL and how do you handle it? Null signifies missing or unknown data. Comparisons with null result in unknown, not true or false. Use is null or is not null for checks, and the coalesce function to provide default values. Question 7. What are ACID properties? They are the guarantees that make transactions reliable. Atomicity ensures all or nothing completion, consistency maintains valid states, isolation prevents interference between concurrent transactions, and durability ensures committed data survives system failures. Question 8. What are transaction isolation levels? They define how transactions see each other's changes. From read uncommitted to serializable, each level increases protection against data anomalies like phantom reads, but at the cost of reduced concurrency. Section 2 focuses on joins and aggregation, essential skills for querying relational data. Question 9. What is a join and what are the main types? A join combines data from multiple tables. An inner join returns only matches, while left, right, and full outer joins include rows even when no match is found, using nulls to fill gaps. Question 10. What is the difference between inner join and left join? Inner join returns only rows that have a match in both tables. Left join returns all rows from the left table, regardless of a match. Use this with a where null check to find missing relationships. Question 11. What are aggregate functions and how do they work with groupie by? Aggregates like count or AVG summarize multiple rows into one. When used with group by, they compute summaries for each group. Any non-aggregated column in your select must be included in the group by clause. Question 12. What is a self-join and when would you use one? A self-join is when a table is joined to itself, using aliases to treat it as 2 separate copies. It's the natural tool for hierarchical data in a single table, like an employees table, where each row points to its manager's ID. Question 13. What is the difference between union and union all? Both combine result sets vertically and require matching columns. Union removes duplicates, which is slower, while union all keeps them, making it faster. Use union ALL unless you specifically need to deduplicate. Question 14. How do you find the second highest salary in a table? You can use a subquery to find the max salary less than the overall max, or a window function like densi_rank. The window function is robust and handles ties correctly by ranking salaries distinctly. Question 15. What is a cross-join and what are its risks? It produces a Cartesian product, pairing every row from table A with every row from table B. This can create massive result sets and is often the result of a missing join condition, so use it carefully. Section 3 moves into advanced queries, where we explore more complex and powerful ways to manipulate and analyze your data. Question 16. What is a subquery and what types are there? It is a query nested inside another. We have scalar subqueries that return one value, multi-row subqueries used with operators like in, and correlated subqueries that reference the outer query and execute per row. Question 17. What is a CTE and why use it? A common table expression, defined with with, creates a named, temporary result set. It improves readability by breaking complex logic into sequential steps. And unlike subqueries, it can be reused multiple times or even be recursive. Question 18. What are window functions and how do they differ from group by? Window functions compute across related rows, but do not collapse them, meaning every original row remains. You use the over clause, often with partition by, to define the window of calculation. Question 19. What is the difference between rank, dense_rank, and row_number? Row_number is always unique. Rank skips numbers after ties, for example giving 1, 1, 3. Dense_rank doesn't skip, giving 1, 1, 2. Choose based on how you need to handle tied data points. Question 20. What is a correlated subquery, and how does it affect performance? It references outer query columns, forcing it to run logically for every row in the outer table. This can lead to significant performance bottlenecks, so rewriting as a join is often preferred. Question 21. How do you pivot rows into columns in SQL? You use conditional aggregation. By wrapping a case expression inside an aggregate function like sum, you can turn distinct row values into separate columns based on defined criteria, while grouping by the primary entity. Question 22. What is a recursive CTE and when is it useful? It is a CTE that references itself, making it perfect for walking tree structures or org charts. It consists of an anchor member and a recursive member, and always needs a termination condition. Section 4 focuses on performance and design, where we look at how to structure your database and queries for efficiency. Question 23. What is an index and how does it improve performance? An index is a B-tree data structure that speeds up data retrieval. It allows the database to locate rows without a full table scan. However, indexes take extra space and can slow down data modifications. Question 24. What is database normalization? It's the process of structuring data to reduce redundancy and prevent update anomalies. We move through normal forms like 1NF, 2NF, and 3NF to ensure facts are stored in their correct place, maintaining data consistency. Question 25. When would you denormalize a database? Denormalization is the deliberate introduction of redundancy to improve read performance. It is useful for read-heavy reporting, where you want to avoid expensive joins. You must manage consistency carefully through triggers or batch jobs, as you now have duplicate data across your tables. Question 26. How do you read and use an execution plan? The plan shows how the database engine runs your query. It reveals whether the engine performs a full scan or an index seek. Use explain or explain analyze to inspect it and identify bottlenecks like expensive sorts or missing indexes. Question 27. What is a deadlock and how do you prevent it? A deadlock occurs when two transactions hold locks the other needs, causing both to stall. The engine resolves this by killing one as a victim. Prevent this by accessing resources in a consistent order and keeping transactions as short as possible. Question 28. What is database partitioning and how does it help? Partitioning splits a large table into smaller physical pieces. It allows the engine to prune data, only scanning relevant partitions, which significantly improves query speed and simplifies tasks like archiving old data by dropping specific partitions. Question 29. How do you optimize a slow SQL query? Always measure with an execution plan first. Ensure your filter columns are indexed and written in a sargable way. Avoid wrapping columns and functions. Also, avoid n+1 query patterns and ensure your table statistics are up to date. Question 30. What is the difference between a clustered and a non-clustered index? A clustered index dictates the physical order of rows, so the table is the index. A non-clustered index is a separate structure pointing to the data. You only get one clustered index per table, but many non-clustered ones. That wraps up our top 30 SQL interview questions. I hope these insights help you succeed in your next technical interview. Thanks for watching Zito TechVerse. Be sure to subscribe for more tutorials and leave your toughest questions in the comments below.